How do you architect a network? Are small business network designs going to be the same as medium-sized business? What about when you scale up to an enterprise level business? Are data center networks going to be the same as campus LAN networks? Hi, I'm Rich and welcome to the Rich Tech Guy channel. So I'm going to go into a few basic network designs, and what we're going to cover here is not going to be the entire range of what you will see out there in the real world, but this will give you a good baseline to establish in terms of architecting and designing a network. And I will also use this as part of setting a foundation for some future video ideas that I have. So with that being said, let's dive into network architectures. So the first network I'm going to go into is called the flat network. Now this network design is common among much smaller, simpler deployments. You're going to find this in pretty much every home network out there. It's also going to be in a lot of small business network designs. And essentially in a flat network, all devices can connect to all other devices on the network without any sort of layer 3 segmentation, meaning you do not have to hop from one IP subnet to another. Flat networks do not scale. Now, that doesn't mean that people haven't tried to make a flat network scale, but when you do see somebody do that, the network very quickly becomes just a mess. So when you do scale from a flat network, you do need to keep in mind the other architectures that we're going to go into in this video and have that as something to scale towards. Flat networks also have no internal security mechanisms. At most, you might have a firewall at the gateway entrance from the internet, but that's all you're going to have. There will be nothing inside of the actual network. The other thing about this particular diagram is it's showing the firewall, the router, the switch, and the wireless access point as being separate devices. However, that's not really always the case. Sometimes in a flat network, you're going to have your firewall, your router, your switch, and your wireless access point all combined into a single device. This is very common with your home router devices and for really small flat design networks. So next we're going to go into the 3-tier network design, and this is a hierarchical design consisting of the core, the distribution, and the access layers. Now the distribution layer is also sometimes referred to as an aggregation layer. But we're going to start down at the bottom at the access layer. And the access layer is really designed for your user device connectivity. So all of your workstations, things like printers, everything that happens out on, say, an office floor would be connected through the access layer of the network. And the purpose of the access is to essentially gather the traffic and send it up to the distribution layer. Now the distribution layer is going to be your typical layer 2 to layer 3 boundary. So to cross the distribution layer, you're likely going to be having some IP subnet hops, unless of course you're staying within the same work group. Now the other thing about the distribution layer is you are segmenting work groups at that point. So that's where you may have your salespeople on a particular subnet, and then at the business, the HR, will have a different subnet, or your research and development will be somewhere else, separated out logically through VLANs. And you'll be conducting your layer 3 inter-VLAN routing, typically at the distribution layer. At the top of the 3-tier network hierarchy, you're going to have the core layer. And the core is really designed as a high-speed, low-latency backbone for your network, enabling a maximum bandwidth and fast packet switching. Now, as we're looking over this entire diagram of the 3-tier network, this is something that you find very common among campus LAN network designs, and it is very good for enabling what is referred to as north-south traffic. Now, what I mean by that is, as I have placed a compass rose on the image here, is that the traffic, as it moves up and down across the core, the distribution, and access layers, that would be considered north-south traffic. East-west traffic would be, say, from workstation to workstation on the access layer, where you're not really going to have that much activity. The network activity you would see there might be something like a workstation sending a file to a printer. That would be considered more east-west traffic. But the bulk of the traffic load in this network design is going to be that north-south going up to the distribution layer at the very minimum before coming back down to access, or even going on to core, and then from the core going on to, say, a data center. When we're looking back at that flat network and we're trying to think about scaling that up, the step into this hierarchical three-tier design is a very big step. And the way you would go about it, if you were to do that, would be to make that flat network effectively one of your access layer points and then build your distribution and core on top of that. But because this is such a large step, there is really an intermediate step. And so a smaller design of the three-tier network hierarchy is what would be called a collapsed core network, where the core has been merged with the distribution layer. You still have that very much a north-south design to the network. You still maintain your hierarchical design. You are separating out your work groups. You are creating your layer 3 boundaries. You're able to provide security at the distribution layer, but you are not quite building up to needing that super low latency, high speed core network. And this is what you will find typically as a small business scales up into a medium-sized business, is this collapsed core design. So the last network design I'm going to be going into is the spine leaf network architecture. This is a network design that you typically find inside of data centers. You will, of course, find data centers that utilize the legacy or traditional three-tier network hierarchy. However, data centers are moving more into this design due to the advantage that it provides to the unique requirements of a data center. What I mean by that is that the data center traffic is typically more east-west than it is north-south. You're going to have your web servers talking to application servers and database servers to get the data in order to present out to the web. You are going to have application servers that are reading and writing data to the databases. There will be load balancers that are making sure that no one server gets all of the traffic, so you're going to have initial traffic streams hitting the load balancer before being transferred out to another server. And then you're going to have the IP-based shared storage across your entire data center, handling the storage needs for all of the servers. Now, what the spine leaf architecture gives you is a high-speed, low-latency, redundant network architecture to optimize that traffic. The connections between the switches on a spine leaf architecture will likely be layer 3 connections, and then you will utilize a layer 2 extension technology in order to maintain consistent VLANs across the data center. Such a technology would be VXLAN. Outbound connections from a spine leaf network architecture are going to most likely come from the leaf switches. In fact, some network architectures like ACI require that your outbound go out of the leaf switches. And of course, that will actually even connect onto the core network of your campus LAN environment if you are going to a campus LAN as opposed to going out to the WAN. So that's our look at the various types of network architectures that you will likely encounter. Now, I'm not saying it will be exactly as is on these diagrams. You may find variations from that, but this is effectively where you are going to be able to recognize the core design of the network pinned to one of these types of architecture styles. So thank you for watching. If you like this content, please hit the like button and please subscribe for more content to come here on the Rich Tech Guy channel. Thank you.